Hi, good afternoon. This is Mr. Cassidy, and today I'm going to be going over fractions with one-step equations. What do we do? Just to sort of preview the lesson, it might help to think of a tangerine like this, a tangerine that has 16 pieces. If you were eating a tangerine, you could represent that as a fraction here. So the denominator is the total pieces that are inside the tangerine, and the numerator is how many you actually have. So if you had a whole tangerine, that would be 16 out of 16. Notice when we have the same number on the top and bottom, that equals 1. One whole tangerine would be 16 slices out of a 16-piece tangerine. So this is the denominator is the number that it's out of, or the number that could be there if the whole thing was filled, could be there. And then the numerator is how many we actually have. How many we have. And what we're going to learn how to do is how to solve algebraic equations just with one step that involve a fraction. Let's dive in. So, our goal right here is to solve an algebraic equation like this, to try to find what goes where the x is, what number. It's probably going to be a fraction. And we're going to learn a simple trick for how to do that with a problem like this. But first, we need to review some fractions operations. The main skill we need, going back to probably your 5th or 6th grade class, is how to multiply a fraction. Remember, you multiply straight across. So in the fraction here, 3/5 times 4/7, we need to review 3 times the 4. 3 times 4 is 12. And so I go straight across here. 3 times the 4 is the numerator, 12. And 5 times the 7 is the denominator, 35. So the answer to this fraction multiplication problem would be 12/35. Here, check yourself. What's 2/5 times 4/9? You should have done 2 times 4 here to get 8, and 5 times 9 to get 45. 8/45. Remember, you're grouping straight across, and you're going to be using that skill a lot in today's lesson. Let's dive in. Another idea that is going to come up is reducing a fraction. In order to reduce a fraction, you want to look at sort of a diagonally. So here I'm going to look at this 2, and I'm going to look at this 8 and go, oh, can I divide those by the same number? I can actually divide the 2 divided by 2 to get 1. And if I divide the top number by that, I have to divide that bottom number. I'm going to divide that by 2 to get 4 here. So all that's left now is a 1 on this side and a 4 on this side. I can do that with the other numbers too, right? Here's the 5, here's the 15. Both of those are divisible by 5. So I'm going to go ahead and divide by 5 here and get 1. And I'll divide by 5 here to get 3. So now I can multiply straight across. Now I still have a 1 here times a 3 here and a 4 here. And it's a lot easier to do this math here. 1 times 3 is 3. 1 times 4 is 4. My answer would be 3/4. Now, if you didn't reduce at the beginning of the problem, you can always reduce at the end. So remember, 2/5 times 15 over 8. You'd get something like 2 times 15 is 30. 5 times the 8 is 40. And then you could ask yourself, well, what can I divide here? I can divide both of these numbers by 10. And if you divided them both by 10, you would still get the same answer, 3/4. So you can either do it at the beginning of the problem before you multiply, or at the end of the problem when you look at your answer. Here, I want you guys to try one really quick. So try reducing this. Let's try reducing 3/4 multiplied by 5/6. Okay, you should have reduced the 3 and the 6 here. Both are divisible by 3. When you divide by 3, you get a 1 on the top and a 2 on the bottom. So our answer should have been 5/8. 4 times 2 is the 8. All right, moving along. I want to call your attention to some interesting things here, and I want to see if you can figure out the pattern. So here are some fractions that I'm multiplying. Let's see here. I do 3 times 5 is 15 across the top, and 5 times 3 is 15. Okay, that 15 divided by 15, the same number divided by itself is 1. Interesting. 7 times 4 is 28. And 4 times 7 is 28. Oh, again, 28 times 28 equals 1. 1/2 times 2 over 1. Okay, well that would be 1 times 2 is 2. 2 times 1 is 2. Oh, 2 divided by 2, so that's 1. Do you notice a pattern here? Go ahead and write what you think in the Edpuzzle. Awesome. So, hopefully you're noticing that there is a pattern here where the first number is a fraction, 3/5, and the second number is that same fraction but flipped over. Look, the 5 became the numerator and the 3 went down to the denominator. And that happened on all 3 of these. And I notice there's a pattern here. Whenever I do that, whenever I multiply by the flipped over fraction, I got the same answer. I got the number 1 all 3 times. Let's see if you can extend that pattern. So looking below here, can you flip over the fraction to get this to equal 1? You would flip it over and get 3 over 2. Huh, that's interesting. 2 times 3 is 6. 3 times 2 is 6. Again, 6 divided by 6, that gave me 1. Here, you try it. 1/5 times what would equal 1? You should have come up with 5 over 1. And yeah, that would be the flipped over version of the fraction. And yes, that would give you the answer 1. Awesome. So, one thing that we cover in this lesson, and you could add this to your notes, is what's called the multiplicative inverse. Which, boy, multiplicative inverse. And what that means is it's a number, a flipped over version, or reciprocal, flipped over fraction. And the flipped over fraction, when you multiply it, it equals 1. So here, I want you to try. What would be the inverse, or the reciprocal, of the number 2/3? What would be its inverse, or its flipped over version? It would be 3/2. Here, you try one. How about 6/5? What would be its inverse? You should come up with 5/6. And notice these are partners, because if I multiplied them by these inverses, I would always get the answer 1. Well, we're going to use that in our math today. So when we see a fraction, in this case it's a coefficient. A coefficient means the number before the variable. X is our variable, and the number in front of it is the coefficient. So what we see here is we've got 2/5 x equals 4/9. We need to remove the 2/5, and there's a trick here. We could divide by it, of course, but the easier way is to find the inverse. So I ask myself, well, what's the inverse of 2/5? I flip it over, and I get 5/2. I'm going to multiply the left-hand side by 5/2 to reach my goal. Remember, it's flipped over, so it's going to multiply and make the number 1. 5 times 2 is 10. 2 times 5 is 10. I'm going to get 10 over 10, which equals 1. And my goal is just to have 1x there. Now, whatever we do on the left-hand side, remember we've learned this rule, we do on the right-hand side. So I'm going to multiply by that same number on the right-hand side, 5/2. And so to solve my problem, I'm going to multiply straight across. First, I like to check and see if I can reduce. I can reduce the 4 and the 2 here, divide by 2. Get 1 and 2. Now 2 times 5 is 10, and 9 times 1 is 9. And my answer, x, is 10/9. So let's recap our steps here. First, we found the inverse. And second, we multiplied both sides by it. multiply both sides by it. And when I do that, the fraction drops away from the x, and I'm able to get my answer. I can find x. Go ahead and record these briefly in your notes, and maybe this example problem so you remember the steps. Let's try it yourselves. You try it. Solve 1/3 x equals 2/9. Okay. Well, you should have multiplied both sides by the inverse, which would be 3/1. And when we do that, the 3's now cancel out, the 1's cancel out, and all that's left is 1x, or just x. Now 2/9 times 3/1, I'm going to go ahead and cancel out the 3 here, and change this to a 3 because both are divisible by 3. And I get 2/3 is my answer. You should have gotten 2/3 for x. Awesome. So we've learned our main tactic here, and I would probably practice a little more in class. There's going to be some review for you to finish after this. But let's move on to some challenges. Now that we get the rule here, let's try it one more time. Practice with this problem. I don't have 3 problems for you to try, but go ahead and try this one. What do you get for x? Okay, so you should have found, okay, here's the x, so I flip over the fraction by it, I put the 8 on top and the 3 on bottom, and I'm going to multiply it. And whatever I do on the left, I do on the right. 8/3 here. So, now I can cancel things out, and all that's left is x on the left-hand side. On the right-hand side, the 3's cancel out, and both of these are divisible by 4. 12 divided by 4 is 3, 8 divided by 4 is 2. My answer is 2/3. Yet again, 2/3 is the answer. So, what about mixed numbers? They present a little bit more of a challenge, but the first goal is to make them improper. We don't just want to flip over the 2/9 here because it might actually not be just a 2 on the top, because we've got to account for the whole number 3. So let's recap that. Remember, when we have 3 and 2/9, to make this an improper fraction, we do 3 times the bottom and then add it to the top. So I'm going to do 3 times 9 is 18. 18 plus 2 is 20/9. So we do big number times bottom number and then add it to the top. So we get 20/9. Here you practice with 4 and 1/6. What's the improper fraction for 4 and 1/6? We should have done 4 times 6 is 24. 24 plus 1 is 25. So our improper fraction is 25/6. So let's rewrite this problem with an improper fraction. 3 and 2/9 was 20/9. 20/9 x equals 25/6. And our goal now is going to be to solve. Go ahead and finish solving this problem using the strategy we learned in the previous slides. Well, first you would multiply by 9/20 on both sides. And I'm going to do some cross-canceling. So 25 and 20 both are divisible by 5. You get a 5 here and a 4 here. And 6 and 9 are both divisible by 3. I get a 2 here divided by 3 and divide by 3 and get a 3. So I get 5 times 3 is 15 over 2 times 4 is 8. 15/8. Now you might be saying, should I change my answer into a whole number? It sort of depends on the problem. Sometimes in algebra, improper fractions are actually easier for us to deal with, so I'm fine with you leaving your answer as an improper fraction. X would be 15/8. How about negative numbers? Well, with the negative number, we're going to multiply or divide by the negative. So in this case, -2/11, I'm going to go ahead and multiply times, I'm going to put that in parentheses, -11/2. And here's why. And whatever I do on the left-hand side, I do on the right. So negative 11 over 2. And the reason why is I want the 11s now to cancel out, the 2's to cancel out, and I want just one x. So the negative times the negative makes it a positive. I'm just left with the positive 1x. So if you see a negative number with the x, remember, multiply it by a negative fraction. Multiply it by the exact flipped over fraction, but negative. Now I would finish out this problem by going okay. 5 and 2 can't cross cancel. 22 and 11 can. So 22 divided by 11 is 2. 1. And so I get 5 times 1 is 5. 2 times 2 is 4. 5/4 so far is my answer, but I've got a positive times a negative. And that's where we go to that rule. Positive times a negative is a negative. So negative 5/4 is our answer. Okay, that concludes our video. You're going to want to get some more practice, but hopefully that goes over all the main ideas for how to multiply or divide a fractional coefficient with x. Thank you, your minds and your hearts, and I wish you a good math afternoon. Bye.